Hello and welcome back. This is part 3 of annotations of our Unified Engineering 3D, E3D 4.0 series on creating intelligent drawings. In the first 2 sessions, we focused on labeling. In part 1, we learned the fundamentals of labels, how to create them, and how to position them intelligently. In part 2, we explored advanced tools like pipe end labels and auto-tagging, giving us a faster and more consistent way to annotate our drawings. If you missed either of those, be sure to follow the playlist so you can catch up and get the complete picture. In this session, we move forward to another essential tool, linear dimensions. Let's begin by opening our drawing sheet and setting up the view for dimensioning. We'll look at how to create linear dimensions in E3D Design, how to control their placement and formatting, and how to make sure they stay consistent with project standards. We'll start by introducing the different types of linear dimensions available in E3D Design. There are 3 main types. Chain dimensions used to place a series of measurements end-to-end along the same reference line. Combined dimensions where the dimension is shared, allowing values to be shown both to the left and right from a common reference. Baseline dimensions where all the dimensions start from a single baseline, making it easy to compare multiple distances from one fixed point. Let's begin by creating a chain dimension. Here, we select P-points and plines that are linked directly to the 3D model elements. In this way, the dimension is not just a static number, it is intelligent. Whenever the 3D model changes, the chain dimensions are updated automatically, keeping the drawing consistent with the live design. Next, we'll move on to the combined dimension. This is similar to chain, but instead of continuing in one direction, it gives you dimensions both ways, left and right, from the chosen reference. In this case, I'll use Snap to Graphics because I'm taking reference directly from the graphical elements on the drawing, rather than linking back to the 3D model. What's important to note is that the dimensions displayed here are cumulative distances. Each value is measured from the reference point to either the left or the right of the drawing. Next, we will create a combined right dimension so you can clearly see the difference compared to the combined left. You can see the differences in the 2 dimensions and the arrow's direction. Lastly, we'll move on to the baseline dimensions. Here, every measurement starts from a single reference line, the baseline. Instead of being cumulative like chain or combined, each dimension is independent, always measured from the same fixed point. And with that, you've now seen how all the various types of linear dimensions look and behave inside E3D Design. Chain, for sequential measurements. Combined, for cumulative distances in both directions. And baseline, for consistent measurements from one fixed reference. Now that we've introduced the different types of linear dimensions, we're ready to begin the lesson proper. In this section, I'll give you a detailed, step-by-step explanation of how to actually create dimensions in E3D Design. Let's start by clearing out the dimensions that we created earlier. To do this, I use the Draw Explorer, navigate to the Dimension layer, and simply delete the layers. We need to display the Active Properties form. Remember that any annotation you create, including dimensions, is written into the current view. The snap that the view used is also based on the current view. That means it's important to double-check that the view you've selected is the one you actually want to dimension. Using the Select view, we can change the current owner in Active Properties. Since we want our dimensions to be associated with the 3D model, the next step is to adjust our snap settings. Instead of using graphical snaps, we switch to the snaps available in View Intelligent. This ensures that the points we pick are not just on the drawing, but are linked directly to the 3D model. By doing this, the dimensions will stay intelligent and will automatically update whenever the 3D model changes. Now let's refine our snap settings before creating the dimensions. I set the snap mode to P-line, which allows me to snap precisely to the start and end of the P-line for gen sects. I turn on P-points, so that I can snap to the exact reference points defined in the model. Let me display the active visual style. The way annotations are created, including our dimensions, depends directly on the visual style settings. I use the combo pull-down to change the dimension settings to the one we created earlier, called TDS Dim Black. We are starting our chain dimension. I select the orthogonal chain dimension option, and then begin selecting the dimension points. I use the snaps we defined earlier to pick element-related dimensions. The notification area displays each selection as I go along. As I pick the dimension points, notice how the cursor changes when it is over a P-point or a P-line. I end the dimensioning by pressing Return. When I select the dimension I just created, its properties are shown in the Properties view. At the same time, the Vertex button is shown. Let's select the Vertex button. Now you can see what the dimension points are referencing. In this case, they are pointing to the P-line or P-point of the 3D elements. As I click through the list of vertices, each one is highlighted in the drawing. Use the Pick button to select vertices in the drawing. The chosen vertex will then be highlighted in the list. This works as the reverse of picking from the list. Instead of selecting a vertex in the list to see it highlighted in the drawing, you pick it in the drawing to see it highlighted in the list. Next, we add a new dimension point to the dimension. To do this, we use the plus handle on the dimension. The plus button changes to red, and then we select the new dimension point. We can also use the before or after dimension point option. Here, the position is calculated automatically based on the edge of the 3D element that we select. Since we want to select the edge of the slab, we use after. Instead of selecting a P-point or P-line, we select the item and switch our snap to that. You can see that the whole slab is now highlighted when we hover over it. The dimension point is added, and we press Escape to end the editing. You can also select any part of the view, and the system will take the 3D coordinate of that location to add the dimension point. For such dimension points, they are static and tied to that specific point. We delete the point, as we do not really need it. Next, we discuss the dimension style. Let's change the style. We navigate to another view to see how this style looks. Let's dimension the pipes on the pipe rack. The dimension appears quite large, and because the pipes are very close to each other, this style is not very suitable. Let's see how the dimension styles are set up. As a drawing administrator, I can edit the style. Normal users will not be able to do that. You'll need to ask your administrator if you want a new style created. I select the admin ribbon and choose Dimensions from the Visual Style tab. You can see the dimension style list, and the form updates automatically when you select a different visual style. Let's find a suitable style to use as a reference for the new style we want to create. We select the copy icon on the form. We give the new style a name. We call this style arrow check. We select Create. You can see the new style in the style list. Let's scroll through the properties, and first, we change the text size. The projection text is independent of the dimension text that we modified. Let's look at the dimension terminator. We can choose the terminator from a list of available terminator. We can modify the size of the symbol for the terminator that we have chosen. There are the linear dimension terminator and angular terminator. Let's use the command line to change the dimension style of the dimension. Let's query the attribute of the LDIM element to see the name of the dimension style reference. The attribute is the dimension style reference, DMSTRF. Let's set it to the new style that we have created. Whoops, I think I got the wrong name. Let's check it. I used small a instead of capital for arrow. We can see the update immediately after changing the dimension style reference. Let's undo the update and use a form that allows us to update the dimension style without using the command line. Besides updating attributes, this form also allows us to copy the attribute values from one element to another. Let's see what happens when we modify the dimension style. When we modify a dimension style, all existing dimensions using that style will be updated automatically. We don't recommend doing this if the style has already been used for some time in the project, as you may need to tidy up the drawings due to the style changes. Now let's use our little tool to copy the style to the dimensions we created at the start of the lesson. By using this system of visual styles, it becomes easier to maintain consistent styling across all drawings. We've come to the end of this session. In this video, we learned how to create and manage linear dimensions in E3D Design, including chain, combined, and baseline types. We also explored how to use intelligent snaps linked to the 3D model, how to edit and add dimension points, and how to work with dimension styles through the visual style system. By understanding these tools, you can create cleaner, smarter, and more consistent drawings that automatically reflect model changes. In the next session, we'll move on to angular and radial dimensions, expanding what we've learned here to cover more advanced dimensioning tools. If you found this lesson useful, don't forget to like the video, subscribe to our channel, and follow the playlist to continue learning. Thank you for watching, and see you in the next video.